Good day, everyone. So today we'll be looking at 7 easy questions. Number 7 is the a energy profile diagram given, and they're asking for each position and also the state of the reaction. Is it endothermic or exothermic? Now, from this graph here, we can see this part, which is the y-axis, is denoting the potential energy, while the x-axis is denoting the reaction part. Now we have a curve. You can see this is a curve, right? So what does this represent? This A plus B, this side written first is the energy of the reactant, while this other side is the energy of the product. So we can refer to C plus D as the product, while A plus B as the reactant. So all this pattern is representing energy, increasing energy upward. Now this from C to D, now this is the product, right? So from here, which is mark 0, down to this point here is called the heat of the product, heat of product. While this other one from 0 mark down to where the reactant is called the heat of reactants. Then the difference between this heat of the product and the heat of the reactant, this gap, this difference here, which is X, is known as the enthalpy change. That's called enthalpy change. And enthalpy change is the product, heat of the product minus the heat of the reactant. So since product now is lesser compared to the reactant, is this reaction, is it exothermic or endothermic? It will be exothermic because reactant is more than product, because we say enthalpy change, heat of products minus heat of reactants. So if let's say product was like 20 and reactant is higher to be 10, sorry, 50, what do you think we're going to get? We're going to get minus 30. And if we get minus 30, that means that it is exothermic because we have a negative. When you see a negative, it means it's exothermic. If it is positive, it's endothermic. It's very, very simple like that. So you just have to look at the graph. If had it been heat of product is greater than the heat of reactant, then it will not be endothermic. Now, what are other terms here? We have answered this question. What are other terms here? So from here down to this point is called the activation energy. From here to here is called the activation energy. But what is this point here? I know here is what the heat of reactant, right? Yes. But what about this highest point here? This is activation complex. Now the distance between the activation complex and the heat of the reaction, now that gap now is what we now call the activation energy. Also take note, the gap between this activation complex and the heat of products now is called the reverse activation energy. Take note of that. And I've explained what V and W, X, Y, and Z are, because V from here down to here, which is V, is denoting the heat of products, while from here down to this point, which is the heat of the reactants, while the gap between them is called the heat or the enthalpy change. Take note of that. So we have answered the question 7, so move to the next one. So in the next question, they ask us, what is the IUPAC name for the compound above? What is the IUPAC name for the compound above? So we can start numbering. Let's say we start from here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the essence of doing this is to know the parent chain. So that's what we are going to use. The longest side, that is the one that is the parent chain, and that is the one we are going to denote first. Now, since we know, okay, either side we count, we are getting 5, so I will just use the straight chain, right? So since I count from here, 1, 2, 3, 4, 5, or I start from here, 1, 2, 3, 3, 4, 5. Either ways, I can count either way, but which one is preferable? The one whereby the functional group, that is we have a lower number or lower count to the functional group, is the one I'm going to follow. So if I start from here, I'll see that the functional group, which is double bond here, double bond is ene abi ehen. So since the functional group here now is at 1 and 2, if we start counting from this side, but if we start counting from this side, it will be 1, 2, 3, right? Yeah, it will be 3. So compare the both of them now. Which one now is shorter? Is that 2, right? So we're going to follow this side counting, not this side. So let's start now. So here will be 1, here will be 2, here will be 3, here will be 4, and here will be 5. So this is now what? Pent plus is 5, pent. But where is this double bond found? In carbon 2. So we'll now say pent. We'll now say pent 2 in. But we're not done yet because we have a branching. Which one? What is the branch there? We have CH3, which is the methyl. Where is the methyl found? In 4. So we can say 4 methyl pent 2 in. So that's the name of this compound. That's the IUPAC name of this compound. Now let's move to the next question. The next question, they said 35 cm cube of hydrogen was packed with 12 cm cube of oxygen at 110 degrees Celsius and 760 millimeter mercury to produce steam. What percentage of the total volume of gas left after the reaction is hydrogen? So in this question, we are going to write out the reaction first. But what we want to calculate is calculate the volume of the hydrogen gas that was left divided by the total volume that was there initially, then times 100. That's what they ask us, not residual gas. Some person will think it's residual gas and add the what we have on the product and the gas left, then they might fill it using that. They will fill it using that. Yeah. So let's solve this question now. First of all, why the reaction of hydrogen reacting with oxygen? So we have H2 plus O2. This will definitely give us water, H2O. But this is not balanced yet. So let's balance it. So this is now a balanced reaction. So do the mole ratio now. You see this is 2:1. Then we have 2 here. So they must maintain this ratio. That's just the key concept. If you can maintain this ratio, you'll be able to get the answer to the question. Now, initially, before the whole reaction occurred, how many hydrogen do we have? How many volume of hydrogen do we have? We have 35 given in the question. 35 cm cube was given in the question. Then how many oxygen was given in the question? Check. Oxygen that was given in the question was 12. So oxygen was 12. So I don't know the one for this one. I put dash there. Now let's now maintain this ratio. How can we? So when they react now, they will react in this same ratio, 2:1. Let's maintain that ratio. How can we maintain that ratio? Now is that we'll bring, okay, so I'll bring 12. What will be here? Here will be 24. You can see. You see that if you divide this in further, we will still get this one here. So that's just the concept behind this. And this will be 24 in this side. So if you see the ratio, this ratio here that we have here is the same thing with the ratio here. It is 2. If you divide this in further, we have 2:1:2. If you divide this further, we get the same thing as the one upward. Now we can now, this is before this packing, this is after this packing. Before this packing, we just write it like that. But after sparking, we write it in their actual mole ratio. Now if you do now, what are we going to get? Then if you do this one, we are going to get 0, while the product side we are going to get 24. Take note, this is, you are minusing this from this from this, and this from this. So you are going to get this value and this. So this is not the gas left, while this is the product. If they ask you for the residual gas, is this gas left plus this product. So this gas left now, they can also call it the excess. They can also use that term excess, calculate the excess. This is what they're asking you. For the gas left, this is what they're asking you. But for the residual gas, is this plus this. Take note of that. But if water was dried out, it's simply the residual gas is simply the gas left. If they should add something that will dry off this water here, if they should add something that will dry it off, then it will just only be this residual this gas left that will be the residual gas. So now let's continue. What did they ask us for? This is not what they asked us for. If you think this is what they ask you for and you pick this one, it's not correct. So this one is not correct. So now what did they ask you for? They asked for the percentage. So it will now be simply 11 over, this was gas left. What volume of hydrogen was there before is 35. So this over 35, then multiply by 100. So if we solve now, anything we get will be our answer. 20 percentage. Now let me type in my calculator. 11 times 100 divided by 35. So this is 31%. So we have 31%. And option B will be the correct answer to the question. So very easy. Now we'll move to the next question. So next question, they ask us a mixture of 0.2 mole of argon, 0.2 mole of nitrogen, and 0.3 mole of helium exert a total pressure of 2.1 atm. The partial pressure of helium in the mixture is what was it? So I will just quickly build a concept on this topic. The partial pressure is equal to the mole ratio multiplied by the total pressure. You get this concept? Very, very easy. And also, the total pressure is equal to the individual sum of the individual partial pressure, B plus, just like that. But this one is too cheap. I'm going to give you this one. So what will they give you is on this one. So partial pressure is equal to the mole ratio multiplied by the total pressure. And what is this mole ratio? X is equals to number of mole of that entity over total number of mole. That's just it. Very, very simple. Now let's apply to this question. In this question, we can say that the total pressure PT is 2.1. Then the number of mole of argon is 0.2. The number of mole of nitrogen is 0.2. The number of mole of helium is 0.3. Now, what is NT, total number of mole? 0.3 plus 0.2 plus 0.2, that is 0.7. That is total number. Now, which one did they ask us for? They asked us for helium. So, what is now the mole ratio of helium? Mole ratio of helium is the number of mole of helium, which is 0.3, divided by the total number of mole, which is 0.7. If we solve this, we are going to get 0 point something. Let me check. I think 3 divided by 7 is 0.428. This is what we are going to get as our mole ratio. Now, what will now be the partial pressure of helium? So, partial pressure of helium is now equals to mole ratio of helium is 0.428 multiplied by total pressure, which is 2.1. So, if we do this, what are we going to get? Times 2.1, this is 0.9 atm. So this will not be the answer to the question, which is option A. Now let's move to the other question. They say the second most electronegative element is, the answer is oxygen, not chlorine. Most people think it's chlorine. So the order of the electronegativity we have the fluorine first, then we have oxygen, we have chlorine, we have nitrogen, other ones. So these are the ones that you need to take note of. You take note of this one. After fluorine, you see oxygen before you see chlorine, before you see nitrogen. Now the second question, say the most electronegative element is, answer is definitely fluorine. So yeah, that's it. Why the second most electronegative element is oxygen. Then the first one, say the element with the highest electron affinity is chlorine, not fluorine. Take note of that of because of the smaller size of fluorine. That is why it doesn't have the highest electron affinity. So what is electron affinity? Electron affinity is the energy that is involved in um, adding an electron to a neutral gaseous atom. So if we have a neutral gaseous atom, let's say this is the chlorine now, and we add electrons to it. There's something like G here, like this. Electron to this. What is this process called? This is called the electron affinity, right? So adding of the electron to the neutral gaseous atom. So that's it. That's all for today's class.